you really want to understand just how ambitious modern naval engineering has become, the USS Zumwalt DDG-1000 is the perfect place to start. This isn't just a warship, it's essentially a floating laboratory of next-generation technologies wrapped inside one of the most unconventional designs ever put to sea. From the moment you lay eyes on it, you can tell this destroyer is operating on a completely different philosophy compared to traditional naval vessels. Its sharp, angular surfaces and inward-sloping sides immediately stand out, and while it may look like a futuristic concept model, every line and surface has been engineered with a specific purpose in mind: stealth. The Zumwalt's stealth capability is arguably its most defining feature. Unlike older destroyers that rely heavily on defensive systems after detection, this ship is designed to avoid detection in the first place. Its shape minimizes radar reflections by deflecting signals away rather than bouncing them back to the source. The materials used in its construction also play a role, incorporating radar-absorbent composites that further reduce its visibility. For a ship that displaces around 15,000 tons, the fact that it can appear significantly smaller on radar is a huge tactical advantage. In simple terms, enemies may not even realize it's there until it's already in position. That unique hull design, called tumblehome, is something rarely seen in modern warships. Instead of flaring outward like conventional ships, the Zumwalt narrows as it rises from the waterline. This contributes to its stealth profile but also introduces complex challenges in terms of stability. In rough seas, traditional hull shapes provide more natural buoyancy and resistance to rolling, whereas tumblehome designs require advanced control systems to maintain balance. To compensate, the Zumwalt integrates sophisticated stabilization technologies, including automated ballast adjustments and real-time motion control systems. These systems constantly monitor sea conditions and adjust the ship's behavior to keep it stable, even in challenging environments. Now, when we move from design to propulsion, things get even more interesting. The Zumwalt doesn't use a traditional mechanical drive system. Instead, it features an integrated power system, which is essentially an all-electric propulsion architecture. Gas turbines generate electricity, and that electricity is distributed across the ship to power everything, from propulsion motors to onboard electronics and weapons systems. This setup produces roughly 78 megawatts of power, which is an enormous amount. To put that into perspective, it's enough to power tens of thousands of homes. But the real advantage here isn't just raw power, it's flexibility. The ship can allocate energy dynamically depending on mission requirements, meaning more power can be directed toward weapons or sensors when needed. This power system also opens the door to future technologies. One of the long-term goals for the Zumwalt class is to integrate advanced weapons like directed energy systems, including lasers, and electromagnetic railguns. These weapons require massive amounts of electrical power, and the Zumwalt is one of the few existing platforms capable of supporting them without major redesigns. Even though some of these systems are still in development, the ship has essentially been future-proofed to accommodate them when they become operational. Speed and maneuverability are also key aspects of its performance. Despite its size, the Zumwalt can reach speeds exceeding 30 knots. But more importantly, it does so with a relatively low acoustic signature. Quiet operation is critical in naval warfare, especially when dealing with submarines or operating in contested waters. The ship's propulsion system and hull design work together to minimize noise, making it harder for enemy sonar systems to detect it. This gives the Zumwalt an edge in both offensive and defensive scenarios, allowing it to approach targets more discreetly or evade detection when necessary. When it comes to weaponry, the Zumwalt represents both innovation and compromise. One of its most prominent features is the Advanced Gun System, or AGS. These dual 155mm guns were designed for long-range precision strikes, capable of hitting targets over 100 kilometers away using specialized guided projectiles. The idea was to provide naval gunfire support to ground forces with unprecedented accuracy. However, the cost of these projectiles became prohibitively high, reportedly hundreds of thousands of dollars per round, which led to the program being scaled back. As a result, the AGS remains an impressive piece of engineering, but its practical use has been somewhat limited. That said, the Zumwalt is far from underarmed. It features 80 vertical launch cells distributed along the edges of the ship. This peripheral vertical launch system is a major departure from traditional centralized missile systems. By spreading the launch cells around the ship, the design improves survivability. If one section is damaged, the rest of the system can continue functioning. These cells can carry a wide variety of missiles, including Tomahawk cruise missiles for long-range land attacks, standard missiles for air defense, and ASROC systems for anti-submarine warfare. This multi-role capability means the Zumwalt can handle threats across multiple domains simultaneously. The ship's sensor and combat systems are equally advanced. It was originally equipped with the dual-band radar system, combining two types of radar for both long-range detection and precision tracking. While some adjustments have been made to reduce costs, the Zumwalt still maintains a highly capable sensor suite. Its systems can track multiple targets at once, integrate data from other platforms, and provide a comprehensive picture of the battlefield. This level of situational awareness is critical in modern warfare, where decisions need to be made quickly and accurately. One of the most revolutionary aspects of the Zumwalt is its level of automation. Traditional destroyers require crews of around 300 sailors, but the Zumwalt operates with roughly half that number. This reduction is made possible by advanced automation systems that handle many routine tasks, from monitoring equipment to managing damage control. For example, the ship uses automated fire suppression systems and integrated diagnostics that can detect and respond to issues without immediate human intervention. This not only reduces manpower requirements but also increases efficiency and response times. Inside the ship, the environment reflects this modern approach. The control systems are highly digitized, with touchscreen interfaces and integrated command centers replacing many of the manual controls found on older ships. Crew members interact with the ship through advanced software systems that provide real-time data and predictive analytics. This allows them to focus more on decision-making rather than manual operation. Living conditions have also been improved compared to older vessels, with better designed quarters and facilities that reflect a more modern understanding of crew needs. Another major area where the Zumwalt stands out is its adaptability. While it was initially designed for land attack missions, its role has evolved over time. One of the most significant developments is its planned integration of hypersonic weapons. These weapons can travel at speeds exceeding Mach 5, making them extremely difficult to intercept. By equipping the Zumwalt with such capabilities, the Navy is effectively transforming it into a platform for next-generation strike missions. This shift highlights the ship's flexibility. It's not locked into a single role but can adapt to changing strategic needs. Of course, no discussion of the Zumwalt would be complete without addressing its cost and the controversies surrounding it. Each ship in the class has a price tag of around $4 billion, making it one of the most expensive destroyers ever built. Originally, the plan was to produce a much larger fleet, but rising costs led to the program being scaled back to just 3 ships. Critics argue that this limited number reduces its overall impact, while supporters see it as a necessary investment in innovation. Many of the technologies developed for the Zumwalt are expected to influence future ship designs, meaning its value extends beyond its immediate operational role. Visually, the Zumwalt continues to capture attention wherever it goes. Its sleek, almost monolithic appearance sets it apart from every other ship in the fleet. The deckhouse, enclosed in composite materials, hides antennas and sensors within its structure, further enhancing its stealth profile. Even the exhaust systems have been designed to reduce infrared signatures, making the ship harder to detect with heat-seeking technologies. Every aspect of the design has been carefully considered to reduce its visibility across multiple detection methods.